In this lesson, we'll look at the cosine rule, which is another rule for non-right angle triangles. For example, trying to find this unknown side x here, where none of these angles are listed as 90 degrees or can be found to be 90 degrees. There's a formal proof of this rule on page 215. You can read through that whenever you want to go to sleep. Okay, however, this is the rule that we'll be using. There's three forms of it for the three different orientations of the triangle. I recommend only learning this bottom one. Looks pretty much like Pythagoras, with a little subtraction to correct for the fact that there's no right angle. So we'll have a go at finding this unknown side using the cosine rule. Again, if you wanted to, you could put a right angle in here, make two triangles, find this using sine rule, sine ratio, and then you'll have to do some simultaneous equations to try and find, and then find this using cosine rule, and then find this, and then Pythagoras to find x. Okay, but it'll take ages. Cosine rule will be more effective. Again, we'll start by labeling the triangle. I'll label the thing that I'm trying to find C. So this unknown side here is C, is my angle C, and label the other ones however I want. So A and B, side B, side A. I'll list the things that I know or that I'm trying to find. I'm trying to find side C. I know angle C is 35 degrees, side B is 12, and side A is 14. From here, I'm going to use cosine rule, but you might be thinking, why can't I use sine rule? Because we've involved all three sides. I would have to use all three of these, and I'd have a double equation. Doesn't make sense. I wouldn't be able to just choose two of them. So I'll use sine rule. I'll state my use cosine rule. I'll state my cosine rule. And then substitute in the values that I know or I'm trying to find. So unknown x squared, 14 squared, plus 12 squared, minus 2 times, what's A? It's 14, times 12, times cosine 35. Okay. And then I need to solve for my unknown. In this case, my unknown is x squared. So to find x, I'm going to need to take plus or minus square root of this whole thing. I'll put this in the calculator in one big go. Remember, I won't put this plus or minus in front when I put it in my calculator. So put it on my calculator, I'll get 8.04. So remember, this is really plus or minus 8.04. And I'm going to reject the negative one. Okay, as negative measurement doesn't make sense. Which means my solution will be x equals 8.04 meters. So that's finding the side. Finding the side is relatively easy as long as we label our triangle correctly. Finding the unknown angle, we can also use cosine rule. Also going to label this the same way. Again, going to label my unknown side or unknown angle using C. A bit lowercase c, and I can choose whichever order I want for the other ones. List what I know and what I'm trying to find. So, trying to find angle C, I know side C, I know side B, and I know side A. So again, I can't use sine rule because it involves all three sides. So I'm going to be using cosine rule. I better state my rule. This is one that you'll definitely need to memorize. And then I'm going to substitute in the values that I know. So C is 11 squared. A is, should be 8, not A. And from here, I just need to solve for that angle C. A common mistake is to put all this as just the one number. Okay, can't do that. If you're going the numeric approach, so a lot of people like to find what these numbers are. So 121, whatever it is, 64, 36, and 96. Okay, and they'll add this together, have 100 minus 96 cos C. The temptation is for a lot of students to write this as 4 cos C. Okay, but we can't do this. I don't want to see anyone making that mistake. The reason why we can't do this is because this is the number 100 and this is 96 cos C. That'll be the same as doing 5 minus 4x being just x. Okay, when you know that you can't collect like terms like that. Okay, so don't make that mistake. Okay, what we need to do is subtract the 100 and then divide through by 96. By minus 96, sorry. And then from here we can find this should be theta all the way through as well. Okay, because that's the angle that I'm trying to find. And then to find theta of this fraction. I ran out of space, but put it in your calculator. 102.64 degrees as that angle. Okay, some people might be more comfortable from here just leaving everything in the squared form, okay, if they want. Okay, and then solving for the theta like that. Okay, that's fine as well. Alright, so the big picture of this is when there's not a right angle, we have two different rules we can use. We can use cosine rule, or like in the previous lesson, we can use sine rule. Biggest challenge students sometimes find is how do I decide which one to use? Okay, here's our decision rule. Does it contain a right angle? No, so I'm thinking either sine or cosine rule. Does the problem involve all three sides of the triangle? If yes, then we'll use cosine rule. If no, we'll use sine rule. Hopefully when you look back at the examples that we've done in the sine rule problems, this didn't involve anything to do with side A, so we'd use sine rule. In the same way down here, this had nothing to do with side B, so we use sine rule. Whereas for the cosine rule problems, we had all three sides involved. And here, all three sides involved in the calculations. So there's some modeling problem and solving questions to have a go at, but before you do them, just make sure that you can do a few of these, finding unknown side lengths and unknown angles. And there's a bit of a challenge problem in question 3. The solutions at the bottom. Alright, good luck.